So we're back at 4.7. I'm going to label this B. It's the second video. But anyway, we left off with this premise. So in case you skipped that first video, remember you want to identify the mins and maxes. Now those mins and maxes are where the derivative crosses the x-axis. And so as I'm looking at the first part of that function is decreasing, that means the first derivative is negative. And then it's increasing, the function's increasing, so the first derivative is positive, decreasing, negative, and then it's increasing to the right, so it's positive. So what we're doing is we're going to, first of all, I'm going to label number 15. If I go back, it's going to take me a while to figure out. So like number 15 is one of the functions. Now what I needed to do is find where the derivative matches up with one of those. So what are we looking at? So I need 3 x-intercepts, and it has to be a cubic. I don't know if it looks like number 12 or that other one. I would say it probably looks more like number 6. I don't know if you would agree, but I'm going to say number 6 matches that. So number 6 is the graph of the derivative of that. But now what I'm going to do is figure out what the second derivative would look like. So again, I would find the max and the min. So the max and the min for the second derivative would then have to cross the x-axis. And now to the left, the derivative is increasing. So that means the second derivative needs to be positive. Then in between, it's decreasing. So the second derivative is negative. And then to the right of that, it's increasing. So the second derivative needs to be positive. Kind of ran out of room. So I'm looking for a quadratic, and I'm going to guess the minimum of the second derivative is to the left of the x-intercept. So before moving on, I'm going to go back to my notes where I named 6. And now I need to find the graph of a quadratic. I'm going to say number 14 looks like it. And then we're done with that first row. And by the way, you don't have to do the problem that way. Let me show you a slightly different way of doing this. Is maybe instead of looking for the largest, sorry, I just moved that thing around, didn't want to do that. Instead of looking for the largest quadratic, is you can look for a linear function and then work backwards. I don't know if I want to do that yet. Maybe I'll do the quadratic one more time. So, sorry, a quartic. So I would say number 9 is definitely a quartic. I don't think there's any quintic polynomials. So I'm going to name number 9 my function f. So let's change colors. Maybe I change, yeah, there we go. So my mins and maxes looks like that. So those need to cross the x-axis. And it's decreasing to the left, so whoops, that's not decreasing. Decreasing has a negative derivative. Increasing, positive. Decreasing, negative. Increasing to the right, so the derivative is positive. So f prime needs to look like that. I don't think number 10 is a good answer for that because the x-intercepts look like they're at -1 and 1. I don't know if anybody's thinking that. Number 12 might look good. So maybe 9 goes to 12. You might look through and see if you can find any better ones. I don't think so. I'm going to say 9 to 12. This is poorly done, by the way. I'm sorry. I'm all over the place with this. I should revise this, but at this point, I'm just going to keep going through, and hopefully you don't hate me too much. So hopefully you kind of agree that number 12 is going to match up with that graph I had earlier. So I'm going to call number 12 my first derivative. So just like before, my mins and maxes. Well, it's increasing to the left, so it should be the derivative of that should be above the x-axis. Then it's decreasing below, then increasing to the right. So I'm going to call that my second derivative. And it looks like the axis of symmetry of the second derivative is at the origin. So I'm looking for a quadratic, maybe number 13. Is there another one like that? Number 1, maybe. I don't know if that's a better answer. I'm I'm going to go with number 13 because if you look at the slope in the middle, it looks pretty steep, like a slope of -3. And that's where this value is. So I think number 13 is the best one. I could see why somebody might argue with number 1. I don't know. Maybe somebody, I don't know about number 3 either. That one looks kind of, that one might actually be better. I don't know, 1, 3, or I don't know, 13 might be where it's at. Yeah, I'm going to stick with 13 because the x-intercepts are at 1, whereas these x-intercepts are at 2. I don't like that. Number 3 might be okay. I don't know. Like I said, this is probably poorly done. So anyway, let's go with 13. I don't want to keep changing my answer. So as I mentioned, what you could do though is you can start with the linear problems. So what am I talking about? Is the linear problems, if this is the second derivative, then what this is telling me is that its point of inflection needs to be at x equals 0. Now, it doesn't necessarily have to be at 0, 0, because here's the thing, is I could have a derivative, a function. So this is, if my second derivative is negative here, that means that the function to the left is decreasing. Pretty steep, I would say. And then to the right, it's increasing. So what I'm saying is you could start with the second derivative and then deduce that its first derivative will look something like that. Now, this could be shifted up and down. We will get to a different thing, so this is not the only correct answer, where you could shift up and down. So that number 7, I would probably match up with number 3. By the way, I don't have an answer key for this activity. This is sort of like, you know, you do it as you please. So if I was looking at number 3 and I was identifying these x-intercepts, all I know is at this point it goes from a positive slope to a negative slope, which means it needs to be a max because it goes from a positive slope to a negative slope. And then right here it goes from a negative slope to a positive slope, so it needs to be a min. So if I'm calling this the first derivative, then this would be what the original function looks like. Let's see. Number 2 looks pretty good on that one. Because remember, you could shift this graph up and down. I'm trying to see if there's another option. I don't think I like any of those other ones. And we didn't use any of those. So I'm going to say number 2 is probably that best option. So feel free to pause the video and try to figure out the last 2 sets. I'm still going to try and work it out because after this is done, you're ready for the homework. And I still have a few minutes before the end of my time. So maybe I would start with, let's see, I think we already did 14. We haven't done 11 yet. I don't think we've done 10. So maybe I'll start with 10. That looks like a cubic would be pretty good. So the max up here, whoops, my min down here. So I'm going to increase first. And then, oh, I keep messing this up. I don't know what's wrong with me. Increase means we're positive slope. That's what happens. You get confused when you switch up the way you do it. Then it's decreasing, so it's a negative slope. And then it's increasing to the right. So I'm going to look for something that looks like that quadratic I just drew. Let's see. I haven't done number 1 yet. I think number 1 matches that pretty good. So maybe map 10 to 1. What did I do? Oh. I'm doing that. What did I just do? $10. All right, so apparently my mouse is just going bonkers. And then after 1, I would probably say, okay, well, here's my, yeah, it's my mouse. Let me plug it back in, see what happens. Right here's my min. So it's got to cross the x-axis. By the way, I said that this was my derivative. Yep, still not working. I'm really struggling right now. I'm about to close this video. Decreasing, so it's below the x-axis, increasing to the right. So look for the linear that we haven't used yet. I don't like number 8, so that's off a little bit. We haven't used 11 yet, I don't think. So maybe I'll say that that's 11. And we only 1, 2, 3, 4. We haven't used 4. Haven't used 5, 6, 7, 4, 5, and 8. I think that's all we have left. So this should be pretty quick because 4 is the cubic. But again, you can identify its max and its min. So the graph of the derivative needs to have these x-intercepts. We'll look at 5. Those are your x-intercepts, like I said they would be. And then right here's your min. So the graph of that derivative would be like that, which matches up with 8, just like that. So survived this video even though my mouse stopped working for some reason. 4, 5, and 8. Feel free to write down any questions, or if you need a better explanation, because this is confusing stuff. Like don't just say, oh, Mr. Higbee flew through those last couple examples, so it must be easy. That's not necessarily true. So this is my answers. And by the way, if I do this next year, I might get slightly different answers because some of those lines look barely different. And maybe that's why I don't have an answer key to this. So anyway, you should be ready for the homework at this point. So I'm going to stop the video, and please, please, please bring questions to class or bring questions to Google Meet. Email me. Let me know what's happening. Keep me in the loop.